Hi everyone, this video is going to be about density. You can see in this picture that we have 2 cans of soda inside a tub of water. We have a can of regular Coke and a can of Diet Coke. Even though these are the same shape, they're the same volume, one is sinking and one is floating. That's because one is heavier than the other. Because regular Coke has sugar in it, and Diet Coke has artificial sweetener, the regular Coke ends up much heavier than the Diet Coke because it needs way more sugar than the Diet Coke needs artificial sweetener. So even though they're the same volume, the regular Coke is going to weigh a lot more. It's going to have more mass. That causes the density to be more than the water, and so it sinks. The Diet Coke has less mass. It ends up with a density less than water, so it floats up towards the top. A very unofficial definition of density is how much stuff do we have crammed into how much space. I really like this definition because I think that it helps you remember the equation, and it's something that you may remember during a quiz or a test because it sounds a little more real life definition. So when I say how much stuff crammed into how much space, what I really mean is how much mass per volume do we have. So if you remember from your math class, when you have the word per, that's implying that you're going to have division happening. So how much mass is fitting in a certain volume? How much mass do we have per volume? How much stuff crammed into how much space? Some common units that you may see in your chemistry class are grams per milliliter, maybe grams per centimeter cubed, kilograms per liter, all sorts of different combinations. One thing that's important to note is that a milliliter and a centimeter cubed are actually the same thing. If I have a little tiny box that's 1 centimeter by 1 centimeter by 1 centimeter on all sides, and I filled it with water, the amount of water that would fit in there is the same as 1 milliliter. So if I'm using something like a graduated cylinder that uses milliliters, maybe I would use milliliters. If I'm measuring something with a ruler, maybe centimeters cubed would be an easier measurement. But it doesn't really matter, you can interchange them because they are the same thing. That comes up over and over during the year, something that you should make sure that you memorize. So our density equation ends up being mass per volume. So which one of these is more dense? The volume is the same, so this time we're going to be looking at the mass, and we use our little particle diagrams to represent the particles we have. The more particles, the heavier the mass. So the one that is more dense would be the one with more particles. This time is a little bit trickier because the mass is different and the volume is different. We don't have the same number of particles and the size of the boxes is different. So here I really have to think about, if I were to compare equal sizes, this one over here really doesn't have as many particles crammed into the same amount of space. So that means this one, this one is more dense. Usually we think of density for solid objects, but it can be for liquids as well. If you pour liquids together that don't mix, they will actually separate themselves out. You can see this with all sorts of common household substances. You can get them to stack in a neat column like that based on their density. The one that's more dense would be at the bottom. And the one that's less dense would be at the top. And then you can actually put objects in there and see where they end up, and it will kind of tell you which one matches the density. So the bolt sinks way to the bottom because it's very dense. Popcorn kernels end up kind of having the same density of that maple syrup. A dice is kind of right in between the milk and the dish soap. So you can use this to kind of unofficially rank things based on their densities. The density of water is the value that we end up using a lot during the year. We do want to make sure we memorize this. If I had my little 1 centimeter by 1 centimeter box, if I filled that with water, it would be 1 milliliters worth of water would fit in there. And that same amount of water would weigh 1 gram. So it's very convenient. While the numbers are really easy, we want to always make sure that we're keeping track of our units when we start doing more complicated math. And so being able to go back and forth between mass and volume, knowing the density of water is all really important. We can also have density of air. It doesn't always have to be a solid or a liquid. We can also have it for air. You can see this when we think about being down at sea level. Down here at sea level, we have more particles pushing down on us. If you go way up to the top of Mount Everest, you might have heard people say that the air is really thin up in a high mountain. And that's because we have fewer particles pushing on us. So we experience less pressure, and that density is not as high. I like this picture because they show you kind of as a column down here. We have lots and lots and lots and lots and lots and lots of particles. Up here, we don't have very many. One thing that's kind of interesting is that this density issue affects how the Earth is. If you remember back in probably elementary school, middle school, you learned that the Earth is made of lots of different layers. We have, the outer atmosphere, we have crust, we have the ocean crust, we have all these different layers, the mantle and the core. The reason that it kind of separates out like this is due to having very different densities. So because these different densities, we end up with discrete layers inside the Earth. When we have the tectonic plates that smash into each other and cause earthquakes, the densities kind of decide what type of earthquake we have. If we have one plate that's much more dense, it will end up going down, and the one that's less dense will end up on top. Sometimes when that happens, we get these ocean trenches that form. Other times it causes pressure and we end up with magma, hot magma coming up, and that's how we can get our volcanoes. So these density of the plates help distinguish the different types of earthquakes that we can see. Another neat thing is that this can actually help diamonds get up to the surface. When these plates go under and over each other, it kind of can bring those diamonds up to the surface. Sometimes you get diamonds from asteroids hitting the Earth, or if the pressure down here gets really high, they can kind of shoot up towards the surface, but the density of the plates is kind of causing them to come up when we have these earthquakes. These pictures are kind of neat from the volcano in Japan 2013. You can see here the lava started to come out, it hits the ocean, cools down. We had two separate little islands here, and as it kept going, It got closer and closer to that other island, and by the time everything was done, we now have one big island due to that volcano instead of two separate little ones like we started. And once again, that's due to the fact that the dense plate went under, the less dense plate stayed on top. We ended up with a volcano, and it can really change how the surface of our Earth looks. So here's some practice problems. We're going to try these. So we're going to start with this one. Jack has a rock. The rock has a density of 6.73 grams per milliliter. And a volume of 8 centimeters cubed, which is the same as 8 milliliters. And we want to find the mass, which we don't know. So we know that our equation is density is mass over volume. So that's going to be 6.73 grams per milliliter equals mass over 8 milliliters. And then I'm going to multiply both sides by 8 milliliters. Remember, you always have to do the same thing to both sides. The 8 cancels. 1 milliliter on top and 1 milliliter on bottom cancels. Over here, 1 milliliter on top and 1 milliliter on the bottom cancels. This shows me that I'll be left with grams as my final unit. 8 times 6.73 gives me my answer of 53.84 grams. Let's try another one. This time, we don't know what the volume is. We know that the density is 1.45 grams per milliliter. And we know that the mass is 15.2 grams. Our density equation is mass divided by volume. I like to just plug the numbers in, rearrange them, but many students prefer to isolate the correct variable before they start. So instead of density is mass per volume, we're going to move volume up to the top and say that volume is mass over density. 15.2 grams divided by 1.45 grams per milliliter. My grams on top, grams on bottom cancels. Milliliters on the bottom of a fraction flips up to the top. So when I punch my calculator, I end up with 10.48 milliliters. 15.2 divided by 1.45. For the next one, we don't know what the density is. We know that the mass is 45.8 grams. And we don't know what the volume is, but we do know that it's 12 centimeters times 3 centimeters times 6.5 centimeters. So when I'm all done, my units centimeter times centimeter times centimeter are going to end up being centimeters cubed. And if I multiply 12 times 3 times 6.5, I end up with 234 for my volume. So density is mass over volume. 45.8 grams over 234 centimeters cubed, and I get my final answer up here. So that's the end of the density video for today. I hope that was helpful. Bye everybody.